first things first, I welcome you all to today's session of I welcome you all to today's session of introduction to ArcGIS. So basically what we are doing today is basically to introduce ArcGIS, to introduce GIS. What is GIS? What can we use GIS for, as well as the GIS environment, like ArcGIS, the software we're using. So we're looking at introduction to ArcGIS. You get to know about the interface of ArcGIS, and we'll look at some data. I hope everybody has downloaded the data sent to the drive. The data that will be used for today has already been sent to the drive yesterday. Has already uploaded there. So if you have not, I implore you to go and do that now. Each is about I think 60 MB of data. I think there's one about 140 something, but it's not much. That's basically like the least data we use in GIS, least amount of data. So please, I implore you to go and download the data. And so let's start the class actually. So I've prepared a PowerPoint presentation we'll be using. So I've prepared. Can you see my slide, please?
Yes, I can see it.
Okay, so I prepared a PowerPoint presentation. So what is GIS? So what is GIS? What do you know by it? So before we actually look at the word GIS, let's look at where mapping originates from. So we'll be looking at cartography. So we know that cartography is basically the science of making maps. Applies graphic aesthetics and other design elements to maps, interprets complex scientific processes and phenomena. So one of the bases of GIS or mapping came from cartography, which is basically the scientific approach of creating maps. So you design, you add lines, you draw regions in order to display places on the surface of the earth. So then, why do we create maps? We create maps to tell story about areas because it brings clarity. And when you're creating maps, it requires lots amount of data. Yes, it can require a lot of data when you're creating maps. So let's look at the example of data. So this is an example of a data, let me just put it like that. Example of data. So this is a data showing states, their population and rainfall. So you have the states in Nigeria, the population of those states as of 2006, and the rainfall in centimeters. So we can see that in Kano State, for example, this data tells us that in Kano State we have average of 10 centimeter rainfall per year. Lagos State we have 15 and all of that. So this data basically gives us kind of a little bit of insight about these regions or these states of the world. But to be honest, they can't actually tell us where these places are located. Yes, we know that, okay, we can compare that, from the population data, Kano State has more population than Anambra State, and Bauchi State is less populated than Oyo State. But we can't actually know where these regions are. So this is where geospatial data comes in. So geospatial data is a sort of data that combines your normal every life data along with location attributes or location data, spatial data. That is a kind of data that tells us, okay, this is where we can use it to pinpoint a particular region, like your longitude and latitude, and maybe northeast and eastings. For most of us are surveying students, northeast and eastings, longitude and latitude. Like for example, this is our normal. This right here is like our normal traversing. So basically, this is basically our node point. Maybe these are our controls. So those controls, we know their northeast and eastings or their coordinates. Then all these points are basically triangulation stations they're basically traverse stations that have unknown points which we want to determine using the principle of traverse. So this kind of thing now, getting those locations, those spatial locations, the northern, eastern, or longitude latitude of each of these points, that data you have acquired is what we call spatial data. The kind of data that can pinpoint the location of an object or the location of a region, that is known as spatial data. So that is why we call this geospatial data. And you can see from the stuff I have here, you can see we have some example. We have the map data, like a normal longitude, latitude, and all of that. We have the attributes, some form of attributes data. We'll talk about all of this later. Satellite imagery, business data. All of this combined together forms what we call geospatial data. So the geospatial data is basically like your normal data added with spatial attributes. Like, for example, in GIS, our data, although that's another part of the course, but let me just bring it in. Our data is split into two. We have spatial and attribute data. So your spatial data is what contains location information, while your attribute data contains other forms of data to describe or to add more value or more form of description to your spatial data. So we'll go into deep about the different types of data later. So like for this here, you can just see when we talk about longitude and latitude. So longitude, what is longitude? Longitude is basically the angular distance east of west of the Greenwich meridian measured along the equator. So this is just a globe showing longitude and latitude. This is just showing you what spatial data can do. If you look at this now, we have 40 degree north, 30 degree west. So once you add this kind of spatial data, this location data to what we had here before, you can now pinpoint that, oh, this region is here, oh, this region is here, oh, this region is here. So this is the essence or the basic principle of geospatial data. Just linking location-based information with your normal data, so you can present it on in a chart of the world, and you can use it for navigation and all of that. So now this is that same data, but it has been repopulated using adding some geospatial columns or some location-based columns here. So you can see now for Kano State, we have the longitude and the latitude, for Lagos and all of that. So with this data now, we can basically plot, or we can basically get the location of this region using this data. For example, if we open this thing here, let's open Google Maps. Open Google Maps, and we go back to that what was it called? Here. So let me take this. Google Maps starts using latitude. So that's what I'm taking latitude here. So we go here. Let's say we paste it here. Use a comma. And then the next thing is here. So you can see that it has taken us to somewhere where, let's see. Kano. So you can see it has taken us to where? Somewhere in Kano. So this is what means geospatial data. Before that, we didn't have this. We couldn't pinpoint, oh, this is where Kano is. But now we have the longitude and latitude. So using some kind of GIS and a sort of geographical system, we can basically now know, oh, this is where it is, oh, this is where it is. So this is just the basis of geospatial data. So this is mapping using geospatial data. So this is just a little map I created using Nigerian shapefile and also some point features. So it's basically, so I mapped this using this. This was mapped using this. I get what I'm saying. So these regions were mapped using this longitude and latitude. So that's it. So mapping geospatial data. So with this now, we can now get some key insights. We can say that, the distance from let's say the central positions, Katsina to Kano, is about half of that from Kano to Bauchi. So we can do some analysis here. You can basically get, let's say someone wants to travel from Oyo to Katsina. With this form of data, just this normal one, you can't know because you don't know the coordinates or the location data. You don't have location data. But with our location data now, we can now say, you can basically pinpoint that, Oyo is north of Lagos, basically. Anambra is about the east of Lagos. I guess what I'm saying. Kaduna is about northeast of Lagos, northeast of Oyo. Kaduna is south of Kano. So with this now, we can basically pinpoint directions, distances, and all of that using the geospatial data. Then let's now go into GIS. So what is GIS? The full meaning of GIS is Geographic Information Systems. Some people call it Geospatial Information System. It's basically the same thing. So what is a GIS? A GIS integrates, stores, edits, analyzes, shares, and displays geospatial data in order to facilitate informed decision-making process. So a GIS is basically like a full GIS application integrates, stores, edits, analyzes. You can use it to make. What is this? Is just saying that you can use it to create, you can use it to manipulate, you can use it to edit, you can use it to analyze. Analyze means bringing out insights. Like from what we did here now, you can say that, oh, Kano is south of Kaduna. I get what I'm saying. The distance from Lagos to Kaduna is more than the distance from Lagos to Oyo. So with the GIS, you can basically analyze and you can share. You can create maps to share with people. You can also display the data. That's like basically sharing. You display it either hard copy or soft copy. So in order to facilitate what informed decision making. Then how does the GIS work? So it said whether you search an address on the internet or like we just did, or map fire truck routes, you can use a GIS to get the information you need. So GIS tools provides tools to find, use, create, and share geographic information with others. For example, you can locate addresses for each of your customers, share this information with your co-workers, and work together to build a customer profile. Yes, you can do that. Functionality and versatility of GIS depends on the system itself. So GIS integrates hardware, software, data, people, workflows into its comprehensive package. So this leads us to the parts of GIS. So the GIS, a full GIS application, GIS system, is made of one, the data. So what is the data? So data is basically what you need. What tells you where, what tells you what. And what kind of data do we use in GIS? Makes of geospatial data. That is, the data contains of both the attributes data and the spatial data. So this data can be in different forms. We'll look at it later. It can be in different kind of formats. And we have software. So we have the software software applications for GIS, just like ArcGIS. That ArcGIS is a very good example. ArcGIS, QGIS, maybe something like Map Info, AutoCAD. Yes, these are GIS software applications. So they are basically applications we can use to analyze data, to bring out insight from data, to create maps and all of that. So then the next thing is hardware. So what is the hardware? So the hardware is basically the engine of your GIS. Yes, so that is the physical. Let me put it in a simple format. Your computer, your laptop, even your phone is an hardware. Anything you can use to that you can integrate software into to make use of the GIS. So that is the hardware. What is hardware normally? Hardware is anything part of the computer system that you can touch, you can feel, you can see. So that's your phone, your laptop, your desktop computer. They are all hardware, even servers. Then people and workflow. So people basically are those as the humanware. They are those people that make use of the GIS. I guess what I'm saying. People that make use of it, like me and you. We are the people. And so the workflow. Workflows is just talking about the process of all of it. So that's for like the basis of GIS. So let's look at some things you can do with GIS. So as previously discussed, okay, what can you do with GIS? So we can use it to map locations. So you said this map, like example, you have a map here. So this map illustrates the location of countries, rivers, cities within the continent of Africa. Location maps can be used to determine where things are situated in relation to each other and are also used in navigation. So you can use your GIS to map locations. Where is a school located? Where does the river pass through? Which places have dense populations and all of that. Then quantities. You can can use it to map quantities. Quantities in the terms of, okay, what are the amount of people living in this place? What are the amount of boys? What are the amount of girls? What's the population and all of that? So this is you can use GIS to map quantities. Are you get what I'm saying? And so, okay, in this region we have 4,000 people living in this city. We have, out of these 4,000, maybe 20% are females, 10% are 20% are females, 80% are males, and all of that. So you can use it to map quantities. You can also use it to know what is inside the region. Okay, schools are in a particular region. You have schools, you have markets, you have all of this. You can also basically use it to monitor, okay, the flow of water, road networks, and all of that. So what else? You can use it to map what is nearby. Let me just give you a hint. There's a particular tool called buffer that you can basically use to know what is nearby in a particular region. You can say that, okay, from a particular location, let's say 50 meter radius from a particular location, I want to locate all the libraries. Let's say you have houses. I want to locate, all the libraries that are about, let's say, 100 kilometers from that, from that house, from each particular house in your map. You can do that using GIS. So with that, you can know that, okay, I have this library here, I have this library here, I have this library here. Sometimes, let's say you want to eat, you want to get food, you don't want to leave your house, and you're like, okay, let me know where are all the, let's say, Glovo restaurants or any form of restaurants within, like, let's say 1 kilometer from my area. That is a place that is not too far. You can map it using GIS, and once you get the location, you can maybe, that's where that location data now, you can use it to pinpoint their location. Then once you now use the attribute data, you can get maybe their phone number. So with the phone number, you can now call them and order. So that is how GIS works. And change, yes, you can use GIS for trend analysis to check changes that have occurred with time. Like, for example, here you have population change. You can see that some regions, you can see like this green regions, there have been a population change from 1.5% to 3.2% from 2000 to 2010. So you can use that to get the average population changes for a particular country. You can to get how much change, apart from even population. You can check houses, the amount of houses. You can check the you can check maybe flood rates and all of that. Any from rainfall, that's precipitation analysis. You can even check temperature analysis. What has been the average temperature of a particular region for a particular amount of years? So you can do all of that using GIS. So this is just a short intro of what you can use GIS for. So the next thing we have to do now is to open ArcGIS Pro, and let's just look at some of the interface. Look at the interface of ArcGIS Pro, and get to know some of the interface, some of the things there. So let me launch my ArcGIS Pro. I would have actually loaded it from the beginning, but yeah, I want to show. So when you load up your ArcGIS Pro, this is what you're going to get. This is what I'm going to show you. So for those of you that have installed, you should get something like this. For those of you that have not installed, please do install, and when you load up, this is what you should get. So let's now create a new project. So you go to map here. So you give your project a name. Let's call this GIS intro. Okay. So you just give it a little time to create the project for you, like you can see. has created the project. Now, because I'm connected to the internet, it will also load up a base map for me. I'm connected to the internet. You can see I'm signed in here. So this is what we call a base map. So in fact, two base maps have been loaded here. You have a topographic map and hue shade. So the topographic map just shows you, like, contour and all of that, while hue shade gives you a more like 3D perspective of the terrain of the land. You can zoom in to see how it is. Let's zoom into Nigeria, for example. Let's say Lagos. Let's say, where am I? I'm somewhere around. Let me not put my location. Let's just zoom on into. So let's just zoom. So this is taking some time to load. Let me off. Okay, so this is the. I'm supposed to be seeing contours normally. Okay, so this is your base map. There are different types of base maps actually. You can add as many as you like, or you can use as many as you like. I think you have to come to map and see base map here. So they will load, so you can choose any form of base map you want. If you want an imagery base map, that will basically show us so something like this. Now this will show you just like you have an area view. Maybe you're in an airplane or you're using drone. So this is world imagery. So you can use different form of base map. So depending on how fast your internet connection is, that's how smoothly it's going to. For mine, it's going very smooth because my internet connection is very fast. The internet connection is slow, it won't be this smooth. But if it's fast, you have no issue. So you can look at this is street base map. Just gives you streets and all of that. So any form of base map you want, you have some of them here already, depending on what you want. So let me just switch back to, I'll just use imagery. So just use a topographic. So now the ArcGIS interface. So you have this project. So project is where you open new projects, you save your project. You can save as means you give it you rename. You give maybe you create. When you talk about save as, you already have a project that you have created that you're working in, but you want to save it and another name, so you can just save as and all of that. Then you have portals. Portals are basically connections. Like for example, if I click this is one, I'm linked to ArcGIS.com. So you have your license, which shows your whatsoever. Shows you that okay, you have license to use the product. And options, all these ones are just, this one does not really concern anybody. So that's just that. So the new is to create a new project. So now for this, so you have the first thing here. Let me start from here. So this is new, to create a new project. You have the open, you have the save. This is undo, to go back, redo, to go forward. Then this is your map. All these here, these are different panels, whatever you want to call them. I call them panels. You can call them whatever you want to call them, as long as it does not confuse you. So you have the map here. So in this map, what can you do basically? So you can, so in your map you have this paste. So let's say you copy something, you want to paste it, you can cut and all of that. You can explore. Explore is basically your primary tool for this. This is explore. So this is your pan tool, just your normal cursor and all of that. So another thing is, so that's that. Then you have this one here, full extent. Full extent just gives you the whole region. So whatever you have here, the layers you have here on your map, the extent, once you press full extent, it gives you the full extent. Let's say maybe your mouse made a mistake and you went down and like this, you cannot find your project anymore. So you cannot find your project anymore. Just click on full extent and it's going to come back. And you have this. This increases and decreases your map depending on a particular scale. And you can see the scale down here. This is your scale. So you have some predefined scales here. You want to do to 1 to 50,000, 1 to 20,000, and all of that. So just if you look as I'm doing this is as you're increasing the scale, you're reducing the map. So increase the scale, reduce the map, reduce the scale, you're increasing the map. So the map of Nigeria can be plotted with a scale of about 1 to 7 million. Then you have your bookmarks. Bookmarks are basically what is it called? They are basically regions you keep so that you can come back to. Like you can create a new bookmark, for example. Let me just call this bookmark based on an extent you have here. So if I call this like bookmark 1, like I gave it, if I go out of this extent and maybe I zoom to somewhere else, unless I want to go back to that map of Nigeria I've made, I zoomed to before, and let's go back to there and it comes back to it. So those are the instances of bookmarks. So this is this is basically like geocoding. You put your longitude, latitude, and you choose which format you want. So it takes you to that particular location. We call this geocoding. So these are based on I've talked about, and this is add data. Add data is basically to, like you said, add data into your GIS environment, your ArcGIS environment. So when you click on add data here, it takes you to your normal kind of Windows Explorer kind of thing. You just go to where you have your data, and like for example, if I come here and import this, you have this map of Nigeria, and if you look at it, basically it aligns with this here. Is it? Yep. So it aligns with what's supposed to be there. So if we remove it, so that's add data. Then you have select. So we are going to look at all this later. Select by attributes and all of that. Select by location. We are going to look at all of this later. You can also download your map if you want. Then insert. So insert is where you can, like, a new map, a new layout. These are your toolboxes, which will be very, very helpful when we start analysis. Then you can actually import them, and this is your connection. So if you are in the previous class where Bolo talked about connections, so this is where you do your connections. So you can add a connection and all of that. So here you can add folder, very, very good. So when you click on add, very, very necessary, you can add the particular folder you're working with. So in fact, let us add a folder. So let's add the folder we're going to be working with. So let's add folder. Actually, what I'm doing here, you can also do it on ArcCatalog. We're going to talk about that later. There's something called ArcCatalog. In fact, I'm supposed to say it. ArcGIS is split into some different packages. Usually, ArcGIS Desktop had these packages separate, but ArcGIS Pro brought all these packages together. So, for example, you have this map. You have that's like ArcMap. You have Scene, that's like ArcScene. You have Catalog, that's ArcCatalog, and all of that. So all of them are being combined in ArcGIS Pro. So we can add a folder. The folder I'll be working with. So let's go to. Let me keep that stuff. 19. let me just add this folder, because this is what we'll be doing our. So now on your catalog here, if you don't have this catalog, you can look at it from where is it? I think there's a map. It's at view, I think. Yeah, so view, you can have this catalog pane. So if you don't have it, you can click on it and it comes out. So on it, you can check the folder. This is the folder we're working with now, GIS intro. So that's how you can add folder. So let's continue. So this is analysis. So on analysis here, you're going to do some, this is where you do some things like Python. You can create a new notebook, write some scripts. This is your geoprocessing tools you use for geoprocessing and all of that. So spatial joins. So all these are just what you do for analysis when you are done maybe arranging your data. Yeah, so this is view. Like I talked about, this is a catalog. The catalog pane is to show the catalog. This here, this is a catalog pane. So that is that. So that's view. Then what else do we need? This is your geoprocessing tools. Yeah, all of that. Then you go to edit. So edit here, this is where you carry out things like georeferencing. You carry out things like, let's say you have a polygon data and you want to like stretch it, you can do it here. You want to delete points, anything you want to edit in your GIS environment, you use this edit. And you can also carry out topology, for those of you who know what topology is. For those of you that don't know, we'll treat it later. So then imagery. So this is where you work with imagery data. This is where you work with imagery data. You know, like classification. For those of you that were in that class where we talked about classification, this is where you carry out your classifications and all of that. So share. This is where like you can create a project package. You can upload to web and all of that. You can even print the map. Future layer. This one is based on the future layer is based on what you target. So if I click on this is going to change. If I click on this, it's going to change depending on the characteristics or properties of this feature. So we have labels, data, and all of that. So that is that for that. So let's just work with some what is it called, geospatial data. Let's just see how it feels like before we go to the different types of data. So I'm going to remove this, and I'm also going to remove this word topo so that it does not just continue burning my data. So let's go to this, where this folder is, this GIS intro. So yeah, we'll be seeing, so these were the files uploaded, and this is the PPT. I've not uploaded, I don't think I've uploaded the PPT yet, but I know I've uploaded these files. So you can go and check, go and download them if you have not downloaded them. So let's just extract this. And let's also extract, find it, this one too. So now let's go back to ArcGIS. So we are going to refresh this place. That's not showing. So this is supposed to be, let me open it again. When it's supposed to open. Supposed to open and show. Okay, you know what? Let me. It's not saying the other ones. Okay, I think. Let me go to. Otherwise, it's still not seeing it. Supposed to be able to see chapter 1 data and all of that. Okay, so yes, it's seeing it now. Let's just add this again. Okay, that's seeing it. So with this now, I can see that we have added folder. So this folder, so that's how you add folder. You just click, you add the connection to your project folder and all of that. So like I showed you before, it's just like the same thing as adding data, but this one is done from the catalog plane. So you just click on the folder of interest, add connection, add folder connection, navigate to wherever you kept your files and work with it. So now let's import some data. I'm going to first of all import this bounding box. So you can just use this to some extent. And I'm going to import state and provinces data. So you can just, it's either you double click it or you drag and drop. Either you drag and drop or you double click it, wherever you want. So this is states and provinces data. Let's also add another data to this. Let's look at population. So population data. So with this now, let's do a little bit of exploration. You can go to the attribute table. Later I'm going to explain the different types of data and all of that. So let's go to the attribute. We are just doing some lookings of introduction to some of the GIS concepts. So like this is what we call attribute data. So you just right click on the layer and click on attribute table. It gives you the attribute data, kind of the form of data I showed you earlier. So you have the shape. This is a polygon data. The states and provinces are polygon data. The populated places, these are point features. We are going to understand what all these are later on. So you have polygon, these are just admin codes. These are some attributes, some documentations for us to understand what's going on here. It gives us the length, the area, it gives us it's either it is African or something, just like an abbreviation. So it gives us the name of each country, this one gives us the type, what type it is, and all of that. So you have other forms of data here. So let's check out the populated places. It seems we are just going to open the attribute table. So you're going to look at points. You can look at this is a point feature. This is a capital type of data. It gives us the name. It gives us the is it a mega city or not? If it's a mega city 1, if it's not a mega city 0, so that is it. Then it gives us kind of name here. I'm thinking this is like which country it falls into. So, and this is the spatial data. You have your latitude and your longitude. That's the spatial data. Then you have population, maximum population, minimum population. So these are other forms of attributes data we have there. So we're just analyzing that. So let's just make a little map. So under the state and provinces now, I can come to label properties. So it is shown here. Then I can say I want to label it using name. So there are different languages. They're either ArcGIS, VBScript, Python, doesn't really matter. So if I want to do I just scroll to the column I want. So let's just look for name. So name, just double click it. So that's it. Each expression is valid and you apply. So this should display all the names of each state here. To be able to, okay, sorry. So we have done that, but we still need to click here, label, sorry. So we just changed label properties, but we still need to come to label here and click label. So that's when I need to show it. Yep, so that is it. So this gives us the labels, shows us the labels for the names of each state here. Then for each of these populated places too, if we want to show their, what was it called? The same thing. We can go to label properties. We can choose maybe name too. Name. Oh, it's already here. Sure it's valid and apply. So we also click on it and click label. So that is it. So this gives us the populated places within each state here. So you can actually off a layer, like off the population places layer, and you can switch it on, off, anyone, off, on. So GIS basically works with layers. So you have different map layers coming together to form a full map. Different layers. So here you can start. We have the bounding box. We have the state and provinces data. That's another layer. We have the, what was it called? The population. That's another layer. Populated places. That's another layer. So each of these layers come together to form the map. So that's how GIS works. GIS works with layers, and each of these layers you can either turn each one off or on, depending on whatever you want to do. Like for example, if I just want to display only the populated places, I will just turn off and I can also, apart from that, I can turn off the labels for each. Like if I click on this now, the labels for all states and provinces is off. I guess I'm saying it's off. So I'm only displaying the populated places. I'm only displaying the populated places. That's only what I'm doing. No, so sorry, I'm only displaying the states and provinces. Let's see. Okay. So now the one for the populated places is now on. So if I want to display only that, and I don't want to display the states and provinces, I just switch it off. So ArcGIS work with layers. So you have to, that's one thing you have to do. Then I was talking about selection. So you can basically make some selections. This is not actually, so this is called identify. Basically, it just gives you a kind of like insight on what a particular thing is. Like when you click on this now, so it tells you this is under the state and provinces layer. The name is Kufra and blah blah blah. So like even this point feature too, when you click on it, it gives you some details about here. Look at some of the attribute details about that particular point feature. It gives you the name, it gives you the sovereign name, it gives you like the latitude and the longitude and all of that. Same thing like for this polygon data too, same thing. So you can just click each one to get to know, just to identify them. So Yeah, you can do that. Also from the attribute table too. From the attribute table, you can do some form of selection if you like. You can do a selection by attributes, like what you have here. Selection by attributes.
When they slap me now.
So we can do some selection, like now you can say that, oh, from state and provinces, what do we want to select? We want to select okay, we want a new selection. Okay, what do we want to select? We want to select, let's say, name is equal to what? What is our name? Let's say we want to select let's say Lagos, and apply. So it has selected it. So all we have to do is just come. You can see you have one of 3,671 selected. So just click on this second region, which shows only the selected one. You can see that what was selected was Lagos. That was selected, Lagos. So that is what we call selection by attribute. We also have selection by location. We have a selection by location. Selection location is based on the layers you have here. Let's say you want to select from the states and provinces data. Features. Repeat features. States. Oh, let me remove this. But we will learn about different forms of selections data. Okay, selection by location is based on a particular selection you did have. So maybe from a particular selection you already have, you want to select something else. So that's how you use it. So we'll learn more of this later though. We'll learn more of it later. So that is that for like learning about the interface of ArcGIS Pro. So the more you use it, the more you get used to it. And for most of us that has just transitioned from ArcGIS Desktop to ArcGIS Pro, some things can be actually a little bit difficult. Something that's very easy to do in ArcGIS Desktop. It's not kind of different to do here in ArcGIS Pro. But you can learn it by using it more, you get used to it. So that is that for that. So I'm going to remove this. So let's just remove some of this data. Remove. So let's now work with what we call different types of data. So we have different types of data. The types of data we have are in general split into two. We have two types. We have the spatial data and the attribute data in GIS. Spatial data and attribute data. Please give me some minutes. Let me load up something. So we have two types of data. We have spatial data and attribute data. And the spatial data is separated into two. We have the vector and the raster. So vector data are data that are made up of what? If a spatial data talks about location-based data, it's divided into two, vector and raster. When we talk about vector data is divided into points, lines, and polygons. So they are basically data that is formed from points. What is point? Point is a zero-dimensional data. It's basically data that just consists of XY pairs, that is northern and eastern, latitude or longitude. That's your point features. You have your line features, which is line features is formed by what is it called? Series of points, like a series of arranged points. That gives you your line features. I will say that the shortest distance between any two points is a line. So a line is basically formed by a sequential joining of points. Then you have your polygon feature, or some people call it area, which is formed by what? Series of connected lines. So a series of sequential connected lines forms your polygon feature. So that is for vector data. So let's learn more about vector data. That's why I want to launch something here. So we're going to learn about vector data. So what is vector data? So it's a data storage method that is composed of coordinate pairs, like I talked about, X and Y pairs, that describes a single point, line segments, or polygonal features. That is point, line, or polygons. Then, what is a point data? So a point data, like I said, is a data that is made up of what? X, Y coordinates, X and Y data, northern and eastern, and all of that. So when we viewed that map, those populated places, they were represented, that is point data. Just points we call them point features. So what can we use point features to represent? We can use cities. We can use it to represent cities like that data we just viewed. We can use it to represent some features like fire hydrants, schools. Yes, we can use them to represent schools on small scale maps. Yes. Manhole covers, tracking vehicles. We want to know the vehicle is, like, let's say a ship now. For example, a ship in the ocean. We want to track the movement of that ship. We're not going to represent that ship using a polygon data. We're going to represent the ship as just a point, because you want to now be looking at, oh, this is how the ship has moved with time. So that's point data. So we got line data now. What do you use line data to represent? Like I said before, line data is made by a sequential arrangement of points. So we use line data to represent things like national borders, like that map we just viewed. Maybe we should go back there. This state and provinces data. If you look at this, all these things are polygon data. This polygon. Now, if you look at that polygon, with the edges there, you have line features. You have line features there. So these line features, you can use them to represent what? You can basically use them to represent national borders, zip code areas, property lines, like surveying now, the boundary line, the perimeter boundary for a particular person. So property lines, transportation and road networks. Your road networks, your river transportation network, pipeline networks, they are all represented using line features. We are going to look at more on this later. Then you have polygon data. Polygon data includes areas that share the same or almost the same attributes: states, counties, city limits. Now let's look at Esri. Now Esri has a feature or a type of data set called shapefile. So this shapefile is what is used to store vector data. So the shapefile has these components you're seeing here. You have the .shp. So that is why anytime I want to send data to you guys, or I want to send geospatial data to you guys, that we use, or shapefile data, we send it in zip folders, because in real world they are not. Look at the way it's represented here. You can see just presented as one like type of data here. But that's not how it is in your. That's not how your system stores it. For example, let me show you how the system stores it. So your system stores it in this form. See? So you can't even know, okay, this is where, you can see that this is where the bounding box starts from and this is where it ends. Now we can look at the different forms of file here and compare it to here. We can see you have the DB file, this is the database file, this is the projection file, this is the SHP shape component file, this is the SHX file, which is all what is here. So the .hsp is the geometry file, which is talking about the drawing features. The SHX is the shape index. This is the database. PRG contains the projection information. Yes, because we make use of projection. Those of you surveying, you might have heard of projection. So projection, like for example, if you're working on like a very large, or let's say small scale map, a map that covers a very large region, that's a small scale map. You'll basically be using, let's say, a map of the world. You're basically using something like WGS 1984. That's a projection. So we have different kinds of projection, though now is not the time for it. But a projection just kind of like display the map for a particular kind of region. You are basically looking at trying to form like a curved part of the Earth surface on a flat plane. That's projection. So every shapefile comes with its projection. Like if you're working on Lagos now, your projection should be based on MENA. Zone 31 N. WGS 1984 Zone 31 or MENA UTM Zone 31. So it contains the projection data. Then you have the .hsp.xml. That's the metadata. Metadata is like attribute data, but it's just a little bit different. You can find the data. We'll look at it on the ARC catalog. So the metadata gives you more information about the shapefile, more description about the shapefile. Like some shapefile, like the shapefile we looked at before, contains some abbreviations. Can give you, okay, what are the meaning? When you see AB, what does that mean? When you see AF, what does that mean? So it gives you more description about the attribute data of the shapefile. So that's the metadata. So these are the components of a shapefile. So all of this combined creates a single file known as a shapefile. So that's how vector data are. So that's anytime I want to send the data to you guys, we always zip it. So other sources of vector data, your CAD drawings from AutoCAD, yes. In fact, even some of the data you get from your GPS is point data, XY data. Yes, you can import it into ArcGIS and use it, and all of that. So let's now analyze some of these vector data. So we are going to remove this and still inside our folder. Let's look at this second file we have here. Navigate GIS. Okay, I think we still have internet data. Internet data. So all these are polygon data. We're also going to look at. Okay, so now let's look at different types of data. I don't like this color, so you can just, if you don't like the color that is appearing, you can click on it and change the color to whatever you like. Let's just keep it ash. So let's look at this school. Let's place it here. So it's adding the data to the map. We can't actually see it, but don't worry. Let's add this sewer line and this one too. Yeah, let's add those three for now. Now you know you cannot see them here, but you can see something here. So what you can do is that you can just zoom to layer. You right click on that layer and zoom to it. So this is it. All those things we added. This is it. So now this, I just brought out this data set to show us the different kind of data we have. So we have this sewer line here. That's line data, as you can see. And we have these sewer points. Those are points data. You can see the presentation. This is a point. This is a line. Then this the schools there. And this is the polygon data representing the school environment or boundary or area, whatever you want to do, school area. So that's that. So these are the different. You have point, line, and polygon. And also the way the attributes table is also a little bit different. For point features, you may be able to see the long and large. If it was calculated, it's not calculated here. It wasn't added. Okay, we can add it later. So, but that just showed you the points, line, and polygon type of data. Now let's look at other forms of data, other forms of GIS data. We have satellite imagery. We have satellite, like the base map I included before. That's the satellite imagery data. It was taken from the satellite. So that's the satellite. Let's add it again. So we can add base map, and there is imagery. So we can remove, this is blocking it, let's remove it, and this is also blocking it. So this is satellite imagery. This is satellite imagery. So it's basically another form of geospatial data we have. Raster, actually, though I didn't want to go to raster, but let's move to raster data so that we can explain it more. So I've talked about vector data. So your vector data is points, lines, and polygons. So let's move to raster data, and let's look at, so that you can understand this satellite imagery and all of that. So let's go to that. So raster data. So raster data is basically, in the simple word, picture. Your normal picture, the picture you take with your phone, with your camera, that's raster data in the simplest form. So there are data that is, we said vector data is made up of points, XY coordinates, points, lines, polygons. The points form the lines form the polygons, but all of them came from the points. For your raster data is made up of pixels. What is pixel? Pixels is the smallest unit for every image, and it also determines the resolution, something we call the spatial resolution of the image. Spatial resolution tells you basically the limits. Like for example, an image that has a spatial resolution of 30 by 30 meters, these are the smallest image captured there. That the smallest rectangular pixel you have there is 30 by 30, and it's anything that is less than 30 meters will not be captured well in that image. Yes. So that's what it's telling you. So raster images are made up of pixels, a rectangular array of pixels, made up of rectangular array of pixels. So you can see what I'm talking about here. You can see rectangle, like grids, pixels, where each pixel here has a brightness level or has a value. Each of these pixels has a value. Instead of coordinates, they have values. So pixels in rows of each pixel can have different value. Value is the average for the cover area measured on the ground. Satellite scenes typically 90 or 30. Like for Landsat imagery now, Landsat satellite captures 30-meter resolution. Landsat 8, Landsat 9, 30-meter resolution. The lower the resolution, the higher the lower the number, the higher the resolution. Like if you have 5 by 5 meter, that is very, very high resolution. If you have, in fact, 1 by 1 or 2 by 2 can only be captured, like maybe you're using drone and all of that. So very high, and the more the resolution, the higher the data, the amount of data, the size of the data, sorry. So we have something called bands. So what are bands basically? Bands are different energy wavelengths captured by the sensor. So we have a type of what we call panchromatic, and we have multispectral. So when we say panchromatic, that is just black and white. That's a single band. What you see is single band, just black and white. And when we say multispectral, that can have red, green, blue, infrared, and all of that. Remember that course I told you guys to go and take? You can go and take it to understand more about bands. So that is that. So we have panchromatic, we have multispectral. I think we also have hyperspectral. So hyperspectral can get, I think, up to like 8 bands or more than that. But multispectral can take 3, like this red, green, and blue you see here. Then Landsat 8 now has 11 bands. So out of these 11 bands, you can combine them to form different spectrum. different band composite like true color, false color, and all of that, made for different form of analysis, whether land use, vegetation, or whatsoever you want to do. So other types of raster data: area or satellite photos, scan map papers. Yes, sometimes your hardware maps, when you scan them and form a digital version of them, they are also forms of data. Yes, and we are going to look at that when we get into georeferencing and digitizing. So scan map papers are other forms of raster data. So the raster data is just like a picture. So, or your picture image. Raster in bands for other data. So when we talk about raster bands, for normal raster, normal like image, maybe with your phone and all of that, you have maybe just a band or 3 bands. Red for true color, just 3 bands. If the one that is multispectral, the panchromatic, you just have 1 band. So that is just telling you. Then the different file format. For vector data, we talk about shapefile. That's the file format. But raster, you can have different. You can have .tif, you can have geotif, you can have JPEG, that's JPG, you can have PNG, that's portable network graphics. You can have even, I think there's SVG. There are many different raster file formats that you can have. So yeah, you can see they also have DEM. That DEM is talking about digital elevation model. We're also going to look at that kind of raster data set. That's another form of raster data set. Yeah, and that is that for raster. So let's just analyze some raster data. So the first raster data I want to analyze here is let me switch off the vector data. Is what is it called? Area imagery we have here. So as you can see, the more I zoom in, the blurrier it becomes. That's because the resolution of this thing is 30 by 30. You can see blur, it becomes blur. But if I look at this is sharp. This is very, very sharp. Very, very sharp, as you can see. But once I zoom in, it becomes blurry. You notice that. So raster images, they have this what is it called? This issue of like when you zoom into them, they become blurry and get more blurry because of the resolution. I get what I'm saying. But if you look at vector data, for example, this vector, let me off the word imagery data now. No matter how I zoom into this, it's not going to get blurry or more blurry. It's not going to do that. No matter how I zoom into it, it's not going to get. No matter how I zoom into this line here, it's still going to be a single straight line. It's not going to be blurry at all, no matter how I zoom into it. So you can see this thing is gone. I can just go to zoom to layer. Where is it? Zoom to layer. So that's the difference between raster and vector. So this is let's just continue with the raster data. Area image. That is, this area image is an image taken from satellites or airplanes and all of that. And as there's been mosaic meat has been combined over time. It has been combined or joined together. Then let's look at another one. Let's look at a slightly different kind of data. Has it been added? I'm coming. I think it's still loading. It's still loading. It's taking time to load. No, I'm coming. It opened the other day. Oh, this data, this is also like an area image that was captured. This .c data. I want this DEM data to add. Why is it failing? Unsupported type. Why? The DEM file. How to connect map. Fail to open raster dataset. Maybe I should just add it directly. Open before. Seems supposed to be empty. Okay, sorry, wait, I'm coming. Let me check from the original file here. Okay, I'm coming. Seems there's something wrong with that file. So let me import from the original downloads. Let me see the name again. Okay. Okay. Let's just wait. It's adding. Again, because why is it taking so much time? Okay, since that one also good, let's look at another one. I think I have another one, so we should not waste our time with that. I think I have another type of data that looks like that. Yeah, let's just use this. Okay. Let me just why is this not adding? So I'm coming. Okay, this is what I wanted to show you. This is a kind of a DEM kind of file, a digital elevation model. This is another raster type of file, basically. So this file, where you have these white spaces, these brightness levels indicate elevation. So this white place you have here is place with highest elevation. This place with the highest elevation. All these white places, you can see the value 66. All these dark places are places with low elevation, and this is 2. Like, let's look at somewhere here. This should have probably a negative elevation. Let's look at 0. So that's basically maybe a water body, and it's true, that's a water body. So yeah, can look all these very dark places. They have very low elevation. So this is 0. These are water bodies. So where you have, so let's look at this land here. So this is 3. So this is just a little bit, the land is just a little bit above the mean sea level and all of that. So this is a DEM file. This is a DEM file here. that's what I want to show you. This is an example. This is a DEM file. So a DEM file basically just shows you you can use from a DEM file. You can create an hue shade. You can create an hue shade. So that hue shade just gives like how the terrain like looks like. You can create an hue shade here. Just hue shade, and I'm just going to feed it this. I'm going to feed it this. Let me just run. I'm going to close all of this. It's probably going to take some time. 6%. I just want to show you how an hue shade looks like. That's another form of raster data. So I think it's done. It's just updating and it should come up any moment. Okay. Yeah, so that is an hue shade. So this is an hue shade basically. So it just shows, as you can see, you can see it looks like your ground, how your ground looks like, and these places, the elevation of these places are higher than these places are lower than this place. You can see this is where we have that water body. You can see it's lower than the land from the hue shade representation. So basically, this is what we call an hue shade, another form of raster data set. Raster data, sorry. So those are the different forms of raster that we have talked about. So we have talked about area photographs, scan maps, we talk about DEM, digital elevation models. We have talked just that shows the terrain, how the terrain of the ground look like. Also hue shades. We have talked about what else? Your area photographs, your scan maps, your hue shades. So those are just examples of raster data. So they are made up of pixels. Yes, pixels, where each pixel has a brightness level or a value. Each pixel has a brightness level or a value. So then you have your vector. Your vector data is made up of coordinates, points, XY, points which comes together to form lines, which comes together to form polygon or area. So those are your two types of spatial data. Then the other type of geospatial data, which is your attribute data. The attribute data, like I said before, we have talked about it, does not contain any location. It's your attribute data gives you more insights on your spatial data to tell you, okay, like let's look at the spatial, but we will not see anything here though. This raster. Well, it's to tell you that, okay, like I said, you may not really see anything in this raster. We tell you this region, this place is this. It's like we saw in the county file. This is Lagos, this is Nigeria, this is blah, this is that. Gives you a representation of all of that. And let me show you what we call metadata. So I just right click on it and go to metadata. You can see it's opening a catalog. So it's from your catalog you get your metadata. So metadata, like I told you before, gives you a very good insight on about your data, like a total understanding of your data, where your data is coming from, the name of the data, what type of data you're here. Have a geodatabase feature class. What type of data is it? The summary of the data, the description of the data, where it was gotten from, credits, use limitations, another kind of thing, the extent, scale, range. It gives you a lot of things about your data, other information that is not in the attribute table. So all of that. So that is what we call metadata. That's what we call metadata. So in your, like I said before, in your ArcGIS, you can also do Python analysis. So that's why you have your notebook. Click on new notebook, you create a notebook basically. So after you create the notebook, you can run Python in your ArcGIS. You run on your ArcGIS Pro, you can run Python. So let's just wait for it to go so that we run some little Python. This is taking time. Well, let's just wait. One thing you have to know about ArcGIS Pro is that even your system has to be strong enough to carry it. Like literally now, my system is just spinning, the fan is spinning and all of that. So you need to have that's why there are some system requirements before you install ArcGIS Pro. You can't just put it in any system actually. It's very, very heavy on system power. The system is not strong enough to crash multiple times when it's basically just loading something like notebook. So I advise you that if you know that you don't want your work to be, you don't want to be losing your work, you can get a capable system. You can go to see their requirements and just meet up the minimum. So this is our notebook. It's just like a normal Python notebook for those that code in Python. So we can write some codes. For example, we can say print hello world, and we run it. So to run a particular, this is called a cell. This is called a cell. This is a cell. So you can see this cell is for coding. You have markdown, which gives you like representation. So you can see print hello world. We have printed hello world. So you can run some codes here. Or print, let's say this is A. Let's say this is A. And we can now say print A. So it's going to print it. A is equals to, let's say A is equals to hello world. So it's going to print it. So you can run Python codes in ArcGIS, and you can also link them, like I showed you. For those of you that are in our, I think first or so class, I showed you that the day we're doing what a class, interactive class session. I showed you the things I've done. I was linking my ArcGIS geospatial data with the data I'm getting from my code. So and all of that. So you can write codes here and process whatever you want to do here. So this is a notebook. You can also form reports. You can create a report based on your findings and all of that. So this is basically just an intro class. We'll go deeper in all these things later. So if there's any question, just put it on the chat box. And we have another session tomorrow, and there will be an interactive class session, which will be, I think, Friday or so. It will be told to you by Bolu. So just make sure you attend classes and all of that. So if you have any question, but when it's time for interactive session, you can ask your question. So this video is being recorded as everything is going on. You can either to be uploaded, you can go back to watch and do everything step by step later on your own. If you have not downloaded the data, please go and do so. And the PPT will be uploaded latest this night, because I have some jobs and all of that. So thank you, and that should be the end of the intro class for today.
Bolu, I think you are talking, but we can't hear you.
Bolu, over to you.
Can you hear me now?
Yes, but it's still a little bit low.
Am I very audible?
Hello, Bolu.
Yes, you are audible. Because we are good.
Okay.
Bolu, your voice is very low. Save the recording first. Yes, it's somewhat better.
Yes, I can hear you.
important for you to stand out with that. Whatever I like, once you ask, whatever I like, I just like moving our life.
Okay, Bolu. Can you hear me? Yeah. So the thing is, I don't know if it's my own end. Like, I'm actually struggling to hear you, but I will assume that it's not just my end. And I'm trying to place how it's said.
It's not just your end, actually.
Okay. So, rephrasing all the things Bolu have tried saying, Bolu thanked all of us, like, for attending today's session and all of that. And he also made mention of the fact that we have a YouTube channel, and for our classes starting next week, we'll be making use of our YouTube channel rather. We'll be streaming. You will be streaming live from YouTube. And part of the reasons why we are doing this is to ensure that the recordings are made available immediately. Because when we use Telegram, there are certain edits that we have to make. So, because of that, we will be shifting our platform to YouTube instead. And I think that's it. It was mostly giving you guys accolades for attending, and also the YouTube stating that throughout this week we'll still make use of our Telegram channel, but starting next week we'll be making use of the YouTube channel. I can see that some people want to speak. You'll be granted like audience, but let me confirm if Bolo has nothing to say going forward before I can now take in the questions. Yeah, we can. It's not like we cannot hear you, but like you are not audible. No, like almost like you are using AirPod, and like you are far from the mic or something like that.
Okay, I think I can identify the issue I'm having. I'm connected. Am I audible?
Yes, but it's better.
Is it okay like this now?
Yes, it's okay like this.
Okay, so if I've been able to read everything I said actually, and just like I said, we are moving to YouTube. So yesterday we already have we did yesterday on the website. We had our interactive session uploaded on YouTube. So the only session that has not been uploaded on YouTube is class we had last week today. So that one will just be left on our Telegram channel for now. We will not be uploading that. So you can just come back to Telegram channel to watch that in case you need that. For those joining us maybe for the first time, basically unable to see everyone who joined us very well because I'm not making use of my laptop. So thank you very much for joining today's session. And so I was reached out to allow us speak for today. At the beginning of the session, I said we will not be accommodating questions, but let me just make today an exemption. Someone trying to raise his hand, so I'll just be giving permission for that.
Okay, the first person to signify is Mayeko Afarazak, I think. So I've granted you, Mike. You cannot talk Afarazak. Mayepolu, can you hear us? You are regarded audience. You cannot talk. You can mute your mic, sir. While we wait for Mayepolu to talk or mute himself and talk, is there any other person that has like something to say or question or whatever it is? And because I understand that you are busy, I wasn't able to join in all through the class. So I think whatever this thing that you handle today, we should be able to answer the question. So you are free to go. Mayebolo, if you still do not respond by 3:41, I will take it that you mistakenly clicked on to request the mic. And okay, it's 3:41 already. Is there any other person that wants to talk, please? Once it's 3:42, I take it that nobody's talking or questions are available to be answered. And we will end the class for today. I'm sure that's less than 30 seconds to go.
I think there are no questions. In the absence of anyone, in case you have any question, you can just send it to any of our class platforms. So the link for the attendance has been sent to the Telegram channel. So you can just check it and confirm yes, I sent it. So you can just check it out. It will also be sent to WhatsApp, and as you guys know the drill, it's just going to be 10 minutes. So immediately I've been able to send to WhatsApp. You just have 10 minutes to access attendance. So basically time is 3:42 on my side, but I'll take that 3:43. So by 3:56 attendance is closed. So it's just important to just write your attendance now. So thanks for joining the session. And just like I said, the recorded session will be uploaded on YouTube. It will no longer be on Telegram, on our Telegram channel again. I'll upload it on YouTube soon. So just check YouTube. If you are yet to subscribe to the YouTube channel, you can just subscribe so that you can get notification and click the notification button so that when the session has been uploaded, you just be notified. So thank you very much for joining today's session. I believe one or two things have been learned because I was able to gain one or two new things that have not worked. So thank you, Gozu, for today's session. Thanks to all the admins that joined. And thanks to every member who has also participated in today's session. I'll be ending the stream exactly 3:45.
everybody, you are free to leave, and I'll be leaving now. Bye.
Goodbye.